Hello everyone, in this video we will be discussing on the pin configuration of 8086 microprocessor. What are the different pins of 8086 microprocessor and what is the functionality that would be discussed in this video. So let's start our video with first of all, the objective of this lecture is to help the students to gain knowledge in 8086 microprocessor pin configuration and their functionality. So coming to the first one, this is the total pin configuration of 8086 microprocessor. Out of these pins, first we'll discuss the first two pins of this one. Let's check the first one, ground. The two pins are given in the ground pins, and there is one pin called as clock pin. And this is the clock which has been applied to the microprocessor with a 33% duty cycle. I told you what do you mean by a duty cycle. If you are on period and off period, or if your on period is 1/3 of your the total clock is called as a 33% duty cycle. If it is divided in three parts and one part is an on period and two parts is an off period, then it will be a 33% duty cycle. And these are the two pins, pin number 1 and 20. On the left hand side of your pin configuration are the ground pins. Overall here 8086 microprocessor is a 40 pin IC. Out of these 40 pins, how these pins are being classified one after the other. We started with the ground pin and the clock. Next comes is the VCC. VCC is the power supply. What is the power supply requirement? It is an 5 volts of power supply with a plus or minus 10% of tolerance. So this is about the power supply of your 8086 microprocessor. You require an 5 volts of power supply. Next, you will be having an one more pin, pin number 21, which is a reset pin. So what happens when you go for reset is that all the registers of your 8086 will be resetted to 0. That would be your values would be resetted to 0. Again, it will turn back to 0 value and it will be 0. So this type of this pin is an output pin. When you want to reset your microprocessor, we can provide a high onto this. Automatically, all these registers are being reset. Next one is your the address lines. So you will be having a multiplex address and data lines. Total 16 lines are given as multiplex address and data lines. You know that we had a 16-bit data bus and 20-bit address bus. So these 20-bit address bus are being given by the 20 lines. So here these are the two lines multiplexed with the address and data. Next, you will be having one more is address latch enable signal would be there. And so here once again I will be telling you. So you are having address and data lines. How many are there? You are having A0 to A15, 16 lines are specified for address and data only. And next one is that in this one, the next A16, A17, A18 and A19 are the consecutive which are represented with the address and status lines. And one more line is there, address latch enable, which is used to send the address. Whenever you want to send the address, we will be sending on this high signal and this one that the address will be. Regarding the interrupts, for handling the interrupts, there are two pins. One is a non-maskable NMI, pin number 17, and interrupt request pin number 18. These are the two pins which are used to handle the interrupts. And if at all interrupt is been accepted, the acknowledgement of the interrupt is been given by the pin number 24. When it is given minimum mode, it will be giving an interrupt acknowledgement onto this pin. For having a DMA operation, there are two pins. One is hold, other one is hold acknowledgement. These two pins are used to give the information about whether you want to go for the system buses and run the program that is given by these two pins. Hold is the system buses and acknowledgement is received in a signal. It is an granting and signal that we can hold the system buses. Next one, already I have discussed this one. There are four more pins after A, we have four more pins, which is equal to A16, A17, A18, and A19. These four pins are used for sending the higher order 4-bit higher order address. So the total address lines are from A A0 to A19, which are the pin numbers from 2 to 16, and then 35 to 39. These are the pins which are used to send. So remember, the order of the bits of address is nothing but A0 is 16, 16 till 2, then from 39 onwards, still it will be continued till 35. This is the, in a reverse order, we are having the pin. So next one is about what happens about this when it is once you have sent the address, the next moment it is these lines are free enough. So that will be providing the status information. How this will be providing? So every time there's S6 is logic 0. It is not a logic 0 whenever the microprocessor is working. So next one is indicates the condition of the interrupt flag. So you will be having the pin number 36, which is representing the condition of the interrupt flag. When pin number 37 and 34 or 38, these two pins are representing the information indicate which segment is accessed during the current bus setting. That is been given by this pin number uh, 37 and 38. So these are the pins where we are operating from extra segment. If it is 0001 stack segment, 10 code segment, or 11, it is a data segment. This is the memory segment. I enables are S7. This enables the most significant data bits D8 to D7 or 15 during read or write operations. D7 is nothing but operating. This bit operates when it is 0. When it is 0, it indicates that my high enable signal is active over there. Higher order bus would be taken into consideration. You not only the lower order, higher order bus will be also taken. The next one is the pins over here. This pin number 33 will plays a crucial role over in your 8086 architecture. So when your pin number 33 is dropped to, when I say it is connected to 0 volts. When it is connected to 0 volts, it represents a minimum mode. When it is connected to 5 volts, it represents a maximum mode. So the minimum mode and maximum mode is represented by the pin number 33. If you want to connect it to the 5 volts, if you want to connect it to the maximum mode, connect the pin number 33 to the plus 5 volts. If you want it for 0 volts, and then the pin numbers from 24 to 31 will have the operation. If it is the minimum mode, this will be the operations. If it is maximum mode, this would be the operations. So this is about the maximum operations. Next one, we'll see the minimum mode pins of your 8086. We have removed the previous slide. We can see combined architecture was shown here. Only the minimum mode pins are being shown, and 32 pin is nothing but read signal. Then whole mode of knowledge we have seen read, write, memory or IO, and data transmit or data receive. And these are the pins which are there in your minimum. So the pin number 32 is about the read signal. If this pin goes slow, it will read the data from the memory location. It goes for the reading operation. And when the pin number 29 is low, it doesn't perform the write operation, just performs the read operation. Number 26, it is nothing but data enabled line, data bus enabled. So it would be making, it gives an information where about the data is available on the system buses, you can take that out. So these are the different pins which are related under the maximum mode. Previously we have seen the minimum pins. These are the maximum mode pins which are related with it. So once again, this read is about the reading of signal, and next one is these are the pins which are being given over here. The first one is status lines S0, S1, and S2. If it is 00, it is an interrupt acknowledgement. So these are the left hand side. You can see these are all this one the required. I mean to say these are all the process which it will be taking into consideration when you have to define the bit pattern. So when you are defining it as 000, it is nothing but interrupt acknowledgement 001, reading an input port, write an input port 010, 011 is halt. Like that way, you are having code access, memory read, memory write, all this. So this is about the status line. Next comes is about request and grant. This is about the DMA operation. In DMA, in minimum mode, you are having hold acknowledgement. But here, provision is more over here. There is only one request which can be generated, but here two requests and two acceptance acknowledgement can be given in the form of a request can be given in the form of two request of system buses, and GT will define it up grant over there. And next one is about the log state. So log is used to log the peripherals of the system. This I have told you in the previous video itself or in the lecture that logs are the same. Usually this log is been to avoid any other further usage of this one will provide a log. Next one is what is the status of a queue? Whether the queue is empty, whether queue is not a data that is given by the status of the queue. These two bits define the queue status. If it is 00, the queue is idle. The first byte of the opcode, queue is empty, subsequent byte of the opcode. Whatever the information is there, according to the information, we carry out the results. So overall here, once you are completing this lecture, students will be able to describe the functionality of each pin of 8086 microprocessor. Thank you for watching this video, and I hope you have understood the concept. If you are having any doubt, you can come to me. Thank you.